going to talk about a little bit about wind and a little bit about solar energy. I'll first start talking about wind energy, then go into solar. But at the end, so stick around because at the end I'm going to compare the two side by side. First, who is the Iowa Energy Center? We were created by the Iowa legislators in 1990, so we're 26, going on 26 years old. We receive our funding from anyone that pays a gas or electric bill in the state of Iowa to the tune of about $4 million a year. We are administered by Iowa State University, so we are one of the special centers at the university. Our mission is twofold: to sponsor and conduct research and demonstration and information dissemination in the fields of energy efficiency and renewable energy, and to provide Iowans with reliable, objective information on those topics. Additionally, in 1996, we acquired from the legislators the Alternate Energy Revolving Loan Program. I manage that program. Offers 0% financing for the construction of renewable energy projects. First, I want to start off by just pointing out very quickly how the U.S. energy picture looks and how renewable energy fits into that. You can see that on the left-hand side we have where our energy sources come from. Coal, about 20% of all of our energy in the U.S. comes from coal. Natural gas, about 26%. Crude oil, nuclear. Finally, down here, renewable energy. As of a year ago, about 10% of the energy consumed in the U.S. came from renewable energy. If we were to look simply at renewable energy, you can see it consists of biomass, hydroelectric, wind, and solar. And what's interesting, trended over time, hydroelectric has been in this country for 50 years, or going on 60 years, but wind and solar are relatively new. Wind really came on in the late 1990s, 2000s, and it's taken off, as you can see by the red line. The solar was almost non-existent in this country. Whoops. Well, that's not good. The solar was almost non-existent in this country until the last couple years. And you can see that the trend line for it is growing quite rapidly now. So if we concentrate on wind at the beginning here, this is the wind resources for the country. The purple is the highest wind areas, followed by the oranges and yellows. So the central part of the country, as you probably know, is the Saudi Arabia of wind power in the country, and the northwest corner of the state is a part of that great resource. So we see a lot of wind turbines up in the northwest part of the state, but notice as we move to the southeast part of Iowa, that wind diminishes quite a bit. So we have a division between wind resource and solar resource. If you look at where the actual wind turbines are built in the country, you know, from this graphic you can see that most of the wind turbines are built where the winds are strong and prevalent. There is quite a bit of wind on the west coast and east coast. It's not because their winds are really good like they are here in the Midwest, but rather that the value of the energy that they're producing is really high, which makes the economics more lucrative. Iowa is the 7th windiest state in the country, ranking third as far as total wind capacity. Got about 5,700 megawatts of capacity, with a lot still under construction. About 28% of our energy, our electricity, actually comes from wind turbines in the state of Iowa, which ranks first in the country. And it can power quite a few homes, as you can see. The number of farms that have wind turbines in Iowa is substantial, 400 to 500. So that's why we're here. How does Iowa rank relative to the surrounding states? You can see I listed our surrounding states based on rank number. Of course, we're third in the country as far as installed capacity. But what's even more incredible is if you look at the potential, the first column there, while Iowa is 570 megawatt potential is outstanding. Some of our neighbors like South Dakota, Kansas, Nebraska have substantially more potential than Iowa, but have not taken advantage of it nearly as well. If we were to look at Iowa, this is the wind map for Iowa at 80 meters. The orange again is the windiest area, followed by the yellow and then finally the blues. There are 3,200 little black dots on that map, but most of them are very concentrated into what we would know as the wind farms here in Iowa. And you can see that most of them are located where the winds are quite strong. But if we are to look up in the northwest part, there's areas up here that seem like that there should be a lot more black dots up here that aren't there. And anyone that lives up in that part of the state will recognize these holes where we have a very good wind resource, but not a lot of development. And the reason for that is the wind turbines have to be close to the power lines that you're going to connect those wind turbines to. So if we were to overlay on that map where the transmission lines are, you can see that the wind farms are located strategically to where they can be connected to the grid. So that's the big wind turbines. Now how about these small ones? This is a database that we have acquired with a couple others, given credit for at the bottom of the map. The blue dots represent the larger small wind turbines. So these are wind turbines up in the range of about 100 kilowatts in size. The red dots are down in the 10 to 50 kilowatt range, and the black dots are the residential size. For most hog confinement operations, you're looking at a wind turbine between 40 and 65 kilowatts to meet your electrical demands. Now that will vary quite a bit depending on what part of the state you're in. And if you're in the northwest part of the state, you're going to probably need a smaller turbine than if you're in the southeast part of the state. And an example I have later in my talk, I'll demonstrate that more precisely. But one of the points of this map is that no matter where you go in the state, you'll find wind turbines because we have a very good wind resource. What are the cost of wind energy? Well, what I can tell you is that the base of small wind energy in the state of Iowa as well as the country has changed quite a bit. If I was here 10 years ago, and I believe I was I talked about wind energy. Everyone had the fever to go out and put up a wind turbine because it was extremely popular. The advances of the turbines that you could have bought 10, 15 years ago compared to the turbines that you're buying today were inferior. There have been tremendous technology gains in the design of both the blades as well as the mechanical parts of the turbine that have improved their efficiency and their capability of utilizing the wind in an effective manner. Those technology advances have not come at a tremendous cost. Actually, the cost of wind energy has declined over time, especially with the larger wind turbines. In the wind turbines that you folks are probably interested in, the price has remained relatively stable. So that's not too bad considering you're getting a better piece of equipment at about the same price. And I've got some numbers here you can look through, but how has that technology improved? The capacity factor is a metric by which you can measure how well your wind turbine is performing or how well your solar array is performing. You can see there in the last bullet, the capacity factor for large wind turbines has improved about 8% over the past 5 to 6 years. That is tremendous and very unexpected. We're not seeing quite that gains in solar, but we are seeing quite a few gains as far as capacity factor. For those that aren't familiar, capacity factor is the number by which the actual energy that wind turbine is producing is divided by how much that wind turbine could produce if it could run 24/7, 365 at rated capacity. So at 47%, that wind turbine is running nearly at half speed or half rating all of the time. And that's really good considering that here in Iowa, although we got very, very windy days, we also have a lot of very calm days, especially in the summertime. The cost, you can see, varies tremendously. There's quite an economy of scale when it comes to wind turbines. The very small ones, the residentials, are very expensive. $8,200 a kilowatt hour is something that you would have a very difficult time cash flowing. Turbines in the size that you guys are probably looking at are more in about the $6,000 per kilowatt range. Without incentives, this might also be a very difficult decision to make. When you get up to the very large ones, over 100 kilowatts, you can see that those prices drop as low as $1,500 a kilowatt. So that economy of scale is very apparent. Like I said, the face of wind energy has changed dramatically over time. Here's 3 different wind turbines that are quite prevalent out there. The top left is the Windmatic 15S. It's easily identifiable by its look. Anyone that is driven north on I-35 at the Boondocks exit, this is the turbine that you see. It's a 65 kilowatt turbine, but it's a very old turbine. These turbines were erected out in California about 25 to 30 years ago. Their life had been served out in California. They were sold, pennies on the dollar. The buyers reconditioned them, or so we were told, and they were sold mostly here in the Midwest. They're a sound machine. They're not a very efficient machine, but the big thing is that they are a remanufactured machine. And so the guts that go into that turbine are something that you have to be very careful about. Is the gearbox of the same quality as the original? Are the brakes? Are the hydraulic systems? And so forth. The bottom left is another story. This is the Enertech Model 44. It's a 40 kilowatt turbine. You can see it's on a hog confinement operation. Look very carefully at that picture, though, and tell me if you see anything funny with it. It's only got 2 blades. What happened to that third blade? Well, this is a story of a manufacturer that came into business. The Enertech name was a very good name 20 years ago. Company, but then went out of business. New company comes along, buys the rights to the design and the name. They start remanufacturing the machine according to specs, except for one thing. They changed the blade design. They made the blade design very aggressive, to the point that it was too aggressive in the winds that we see here in Iowa. And it started to burn up generators. And it came to the market so quickly because the fever was so hot that there was not a good chance to really test this in all conditions. The result was blades started to fail, started to fall to the ground, started cracking at the root. And so a lot of farmers, spending anywhere from $150,000 to $200,000 to buy this machine, ended up with a piece of machine that looks like what we see here in the photo. The company went bankrupt. You can't buy parts for it. You can't find anyone to service it. So there's an investment that has no value, and a lesson to be learned that be careful and do your due diligence on who you work with and who you buy from, not only on wind but on solar as well. The Endurance machine on the right is one of the newer machines, still in service. It's a very nice machine, 50 kilowatt, a very efficient machine, and a machine that I'll use an example later in my presentation. There are some challenges for wind. The big one is that there is no standardization. If you were to go out and buy a 50 kilowatt wind turbine from company A and compare it to company B, you're going to get completely different answers. And you're going to get different answers because there is no standardization. If I call it a 50 kilowatt machine, I have to know at what wind speed does it actually produce 50 kilowatts. And that is not standardized. So company A may achieve 50 kilowatts at 30 mile an hour, but company B may not be able to achieve that level until 50 mile an hour. So the comparison isn't there, and so that is one of the challenges with wind turbines of the small wind turbine size. Second problem is the lack of contractors. There is an organization out there that certifies, the North American Board of Certified Energy Practitioners, that certifies both wind and solar installers. You're not required to get this certificate, but this certificate proves that the person has both the book knowledge as well as the construction capability of doing a good job for you. I'll show you the solar results later, but there are no certified professionals in the state of Iowa. We talked a little bit about the loss of manufacturers in the marketplace. In 2005, you might have been able to choose a wind turbine in this size range from maybe a dozen to 2 dozen manufacturers. Today, you might only find 1 or 2. There is a wind turbine manufacturer downstairs, or I guess upstairs, that you'll be able to look at. It's a new turbine to the marketplace that might compete well with the Endurance machine, but it's a brand new machine, so we don't really know at this point. But you don't have a lot of choices, so we not only lost manufacturers, most of it that have gone bankrupt, but the people that service this equipment have also left the marketplace. So quality and performance issues are something you have to worry about, as well as warranty and service issues. Expect maintenance issues with wind turbines. They are made of moving parts. Moving parts require maintenance and service. Quickly, let's go to solar energy. Why we should care? We should care because the growth in solar energy has become phenomenal. For the first time, solar energy overtook wind energy worldwide in 2013 by a wide margin, especially when you compare the growth or the installations in 2012. And it's predicted that solar energy will continue to rise and increase at a very rapid rate, such that in 2014, the amount of solar installed doubled what it was just the previous year. And in 2015, I don't have the numbers yet, but it looks like it yet doubled again. So why is all this happening? Historically, solar has been too expensive to even consider at $7 to $10 a watt. Compare that to the $6 a watt that I showed you earlier for a wind turbine in the size that you're looking at. However, the worldwide economic recession that we had provided opportunity for this industry to grow. That, combined with the Chinese creating the world's largest surplus of polycrystalline silicon, which is the raw material that goes into the solar cells, it drove the price way down as low as $1 to $2 a watt for the solar modules themselves, and installed costs as low as $2 to $5. Here in Iowa, those installed costs are roughly $3 per watt. Very competitive compared to what it used to be, and very competitive with the wind alternative. However, what are its challenges? There's relatively few PV installers in the state. There are only 13 certified solar installers in Iowa. Compare that to some of our surrounding states. Both Minnesota and Wisconsin have 44. So there is room for improvement there. The solar energy is quite simple. There's no moving parts. The sun hits the solar module. That solar module makes DC power. That DC power is then either stored in batteries, which I almost never see, or it's inverted to AC power to be used in your buildings. There are 3 different types of modules: single crystalline, multicrystalline, and thin film. What we see mostly is the single and multicrystalline. Single crystalline has its own distinct look, very black with very uniform cells. It is the most efficient of all the technologies. The multicrystalline has most times a blue haze that you can see in it. It's less efficient, but it's more agreeable to if you have conditions that include shading. The solar resource for the country, the best resource is in the red there down the southwest, and as you move northeast to the greens, it diminishes. But the resource here in Iowa is fairly uniform. Notice that in the northwest part of the state, up by Fort Dodge, has the same solar resources down in Burlington. So the resource is opposite that of wind. Our best resource is in the southwest part of the state and diminishes as you move northeast. Solar is really taken off in this state. You can see all of our utility companies have embraced it and installed significant arrays, and the plan for future installations, again, is quite high. Out on the farm, this is what a typical installation might look like. You can install them either on the ground or on the roof. On the bottom right photo is a string of string inverters that take the power up on the roof and invert it to AC power that then feeds the confinement building. Ground mount is also possible for those that don't want to put it on the roof for whatever reason. Can make some really nice installation, but solar is not without some thought behind it as well. Maintenance. If you put it on the ground, you may have to contend with vegetation growth under it. Certainly the top photo, the structure is such that getting in there and cleaning out that vegetation is more work than the owner thinks it's worth. The bottom left shows that it can be maintained using cantilever type structures, or in the bottom right you can simply replace the vegetation with a soil fabric and gravel. You also have to worry about soiling, especially in your environments. These are pictures I took last fall. The left-hand photo there is a multicrystalline, so those are black, supposed to be black solar cells. I tried and I tried with a dry finger to get through the dust of this particular facility, which was at a hog confinement operation and on a gravel road. And that's all better. I could wipe it clean. That's how thick. That level of soiling, what we call soiling on the solar panels, will cut down 20 to 25% of the production of the solar panels. So in this particular environment, cleaning these once in a while may be worthwhile. Now, you remember last fall, we didn't have a lot of rain. So when we get the morning dew and that dust settles on it, it stays on it. On the right-hand picture is bird droppings, another thing that you may have to contend with. This is a big one, and this distinguishes good installers from bad installers. On the left-hand side is, are your ground-mounted solar panels agreeable to our conditions here in the Midwest? Notice on the top left photo the height difference between the right array and the left array. And this is done because these solar panels were built on kind of an inclined slope. So trying to keep them all level. Well, the effect is the picture on the bottom right below it is from the exact same array. A couple of weeks ago I went back to look at how did they perform after a snowstorm. The picture down below is 10 days after the snowstorm. And you can see that the bottom edge is completely covered with snow, which will diminish the output of the solar array dramatically. And so either a guy has to go out there and remove the snow if he wants full performance, or he just concedes that he's got to live with it. But a very small detail on how high to install those can have quite a bit of effect that people may not have even considered. Take the right-hand photo. This array is right next to a road. The hog confinement, you can see the feeders in the background are behind it. But look at the position of the array relative to the power poles. Look at the shadow that's being cast. No one probably even considered that that power pole was going to cast a shadow. But it's going to knock out, in this picture, it's knocking out 3 to 4 solar modules. When I throw a shadow on a solar panel, especially on the single crystalline modules, it will knock out the entire string, or the performance, the entire string that it's attached to. Typically, your strings are 9 to 17 modules in a string. That kind of solar can be really bad unless provisions are made. And there are provisions to be made. I want to mention that the Iowa Energy Center has a brand new home series guidebook that is coming out hopefully next month. It is a how-to, and I would highly suggest that you go out to our website and find it next month and go through it. It goes through step by step. What are the questions you need to ask, and what kind of information do you need to have? It was written specifically for folks like you to make you more informed consumers. There are a number of incentives. I don't have time to go through them very detailed, but I think you will have copies of these slides. There's a lot of federal investment tax credits that were just extended here a month ago. They will be phased out over time, the wind ones. The solar investment tax credits were extended until 2020, at which time they start to phase out, and you can see the phase-out levels. So the wind in 2020, those investment tax credits disappear, whereas on solar after 2022, they'll remain 10%. Iowa has its own solar energy income tax credit, currently equal to 60% of the federal level. It is due to expire at the end of this year. I expect that there will be some effort in the legislature to match the federal phase-out times. There's accelerated depreciation incentives that you can use for this equipment. I talked a little bit about the loan program that I manage, offering 0% money, and that bottom, the database for state incentives for renewable, is a website that you can go to get detailed information on all the incentives that are out there. So let me conclude with a comparison of wind and solar. On the wind side, I chose an Endurance 50 kilowatt turbine. It's a popular turbine on a 120-foot tower. Compared that to a monocrystalline solar array that cost about $3,000 a kilowatt. If I am located up in the northwest part of the state and I chose Alta, Iowa, my wind turbine would have a capacity factor of nearly 42%, producing about 184,000 kilowatt hours a year at a cost of $300,000 to $335,000. If I put that same system or had that same site and put a solar system in, my solar system with that monocrystalline is going to have a capacity factor of about 16%, and I would need 132 kilowatts of solar to produce that same amount of energy. The cost at $3 a watt would be about $395,000. So because the wind resource in northwest Iowa is so good, the cost of putting solar up in northwest Iowa may not make a lot of economic sense. Wind and wind energy in the northwest part of the state make a lot of sense. If I was to move down to Washington, Iowa, same equipment, my capacity factor for that wind turbine drops from 42% down to 31%, so its output is now only 135,000 kilowatt hours. The cost is the same. The solar system still has the same capacity factor because the solar resource is equal. So I only need a 97 kilowatt solar array down in Washington, Iowa, and it's only going to cost $290,000. So down in the southeast part of the state, the solar may be more economical than the wind. Finally, there are other intangibles that you have to consider. Wind energy, it's a one-time decision. You have to decide today whether I want a 40 kilowatt, a 50 kilowatt, 60 kilowatt turbine. And once you make that decision, you're pretty much stuck with it. Whereas solar, you can easily expand it. So you can start with a small system. You find out that it works well, but it's not large enough. You simply add more modules to it. Wind energy, you only have very finite amount of choices to choose from. And those choices are about less than 5 for the sizes that you're looking at. Whereas solar, I can make it any size I want because the modules are flexible. Wind energy takes a relatively small footprint, whereas the solar energy could take a pretty large footprint. That 100 kilowatt solar arrays could take an acre of land. Do you have an acre of land that you're willing to sacrifice? Turbines are not standardized, but solar modules are standardized worldwide. Wind energy requires regular maintenance. Solar is nearly maintenance-free. A mechanical device versus no moving parts. Wind energy generally has short warranties, 5, maybe 10 years if you're lucky, but generally 5 years. The solar, the inverters have 12-year warranties generally, and the modules have 25-year warranties. Wind energy, though, has high capacity factors where solar is low. Wind may have noise issues. The solar is silent. And then we have to deal with customer support. Where can I get that customer support when I need it?